market basket analysis, which basically has clustering also. It does have something like an association rule mining also as part of that, basically a recommendation engine. So what is market basket analysis? We are primarily looking at some basket of products being bought by customers and trying to understand what is the affinity of products. So what do we mean by affinity? Affinity basically means what is the pull between two things, right? So if you look from the perspective of chemistry, when we learned in 10th standard, so affinity basically meant the tendency of molecules to come together or to attract each other. That is called as affinity, right? And when we use that with respect to elements, items, or products in the basket what a customer is buying, that's called as affinity analysis, or it can also be called as association rule mining. We usually do this most often on text data rather than numerical data, because it doesn't make sense to use it on numerical data, because you're trying to find association between two labeled text data. And the algorithm which is used for this is called as the a priori algorithm, which is part of the a rules package, right? And it's prerogative that you use a data which is in a very specific format, which can be ingested by this algorithm, and that's called an sparse matrix format. And obviously in this, what is required is that the data, although we know that it is possible in retail that a customer can buy a product again and again, but we isolate that and we just consider the unique elements which he has bought. So if he has bought something 3 times, we don't consider it as 3, but just consider it as once purchase, because here the quantification is not considered. Here it is just seen whether it was bought with this product. For example, egg and bread brought together, right? So is there an association that when a person has bought egg, there is a possibility that this person can also buy bread? If he has already bought egg and bread, then is there a possibility that he might buy milk also? It's based somewhere on the Bayes theorem, but instead of specifically concentrating on joint probabilities versus conditional probability, which is always a fight between frequentistic approach of probability and Bayesian approach of probability, we typically just go by using both of them and merge set theory and probability theory together. So it's a bit confusing, but be with me so that you can understand this whole aspect. Typical application would be in supermarket, telecom to understand how is the switching going to happen, in insurance to understand how does a customer purchase, so how can you push a customer from one bucket to another. But more relevantly, you can see this also in something like Google. When you do a Google starts doing something which is called as recommendation. So when you type job, it starts giving you recommendation that job offers this and that. When you say mobile, so you type mobile and it says mobile on sale, it says mobile on Flipkart, and all those recommendations. So you see the 6, 4, 7 lines stacked underneath that. So based on the user's query, so people type something in Google collects that data by way of cookies, and through that it is somewhere sitting on the Google server, and Google runs an algorithm over there which is called as collaborative filtering, which basically filters out that if a person has started with this keyword, then what should be the second recommended keyword. So if I say credit, would card also come after that, or would it be credit market, or would it be credit bank, right? So that would come from the user's pattern of typing, and that is captured and that is used, mined, and again given back to the user as a recommendation. The same which you see on Amazon. When you buy a product or you're observing a product, you will see some simultaneously scroll happening on the bottom tray, on the side tray, that people who have bought this product have also bought that product. People who have seen this product have also seen that product, right? So basically trying to recommend to customers. When you're in YouTube, you click on one type of a genre of movie or clip, and then corresponding the related sequence of videos pipe up in the on the right tray. So this is nothing but application of this technique, right? Now this can be a very simple thing as what you're doing over here, and can get very complex when you look at the recommendation aspect. So the basic terminology is that there are 2 sets, right? So the association between which can be presented, right? So we're using the A rules package, which has the a priori algorithm. So internally what happens is, from a single element to the most complex combination of elements, the algorithm will create a stack, where maybe if it will start as simple as T, say for example, and against that the frequency of purchased T packs against the total number of transactions would be shown. That's probability basically. So if out of 10 transactions, if 2 transaction has T, so that is 2 by 10, that is 0.2, right? Then T along with milk, so this combination would happen say less number of times, say 1 out of 10, so 1 by 10 would be the probability. So this is how it gets stacked internally, and this would be pulled up at runtime to compute the rule based approach, right? So we'll talk about support, confidence and lift as we go forward. So items are objects that are basically coming from transaction, right? And then there is also something which is called as the customer's basket, which is coming from the transaction again, but with a different approach, and you use the customer's ID instead of the transaction ID. So the population for mining the transaction data is coming basis the transaction ID. The population which is used for recommendation is basically coming from the customer ID, which is part of the transaction table, and the master is stored somewhere else, right? And you create the rules out of the transaction, you merge it with the customer's basket so that that becomes a recommendation. In principle, today we are going to talk just about the rule excavation, right? So transactions as instances of group of item co-occurring together, which can be represented as T is equal to I1 to Ij Ik. This gives us a rule which are represented as I1 comma I2 follows Ik. This can be read: if a user buys an item in the item set on the left hand side, then the user will be likely to buy the item on the right hand side too. So for example, coffee and sugar bought together, the probability is high that the customer will buy milk, but we need to give some numbers against this that will come in the next table, right? So we have three things: support, confidence and lift. So what is support? Support is the ratio of number of times two or more items are bought together out of the total number of transactions, right? So it's basically a simple probability of number of times this combination has occurred together divided by the total number of observations. That is the support. Confidence, on the other hand, is a conditional probability which says that if something has happened, what is the probability that the other thing will happen? So if a person has bought tea powder and milk, what is the probability that he'll also buy coffee? That is the conditional probability, and usually represented by P of so we usually refer to support as antecedent and confidence as we usually refer the two sets. So one set which has occurred previously and the other which follows. The one which is on the LHS is called as antecedent, and then the right hand side it is called as consequent. So when you talk about support, it's about seeing the antecedent and the consequent together in the transaction. The antecedent can have one, two, more than two elements also, but the consequent will always have one element only. When you talk about confidence, it's about probability of consequent given that the antecedent has already happened in the transaction. So obviously you're going to do a subset of the overall data, and that is why your confidence as a probability value will always be high, whereas the support as a probability value will always be very low, because it is about huge data and the support will always be a very low value, right? Now lift is the ratio by which the confidence of a rule exceeds the expected confidence. So a very good measure to express this number in front of business, because business will accept the lift value and will not go by the support value, because support is a very small minuscule number, and business will say that the confidence is good but it doesn't have a good support and we cannot run or use this for any kind of campaign. So that is where lift assists you, because lift is not a probability value or a percentage value, but it is an absolute number. And because the lower number, so you are basically doing a support divided by individual support of antecedent and individual support of consequent, which you can see as support of IM into support of IN. And obviously when you're multiplying two probability values, the resulting probability value will still be a smaller number. So the denominator is a very small number, and this impacts the overall lift, which gets inflated.